Friends, good morning to everyone. Today's subject of discussion is photochemistry. What is this photochemistry? This is a reaction which is accompanied or induced by light. How the light can induce the chemical reaction? Why it can induce a chemical reaction? Light is a source of energy. Like heat, we use as a source of energy. Like electricity as a source of energy, light is also a source of energy. Light is an electromagnetic radiation. The best example for photochemistry is the vision. The vision of the eye is triggered by a photochemical reaction. When you look at the flower over here, which we have seen, if I keep this in dark, can the color of this flower visible to us? Definitely not. Why is it so? Here, the light falls on the object, it absorbs some amount of light and reflects some amount of light. And the light which is reflected from this object falls on the retina and it converts cis retinol to trans retinol, and the signals are transferred to the brain, and thus the brain can recognize the color. This is the finest example of photochemical reaction where the cis retinol gets converted into trans retinol. Dr. Walsh, whom I have shown over here, has been awarded Nobel Prize in Medicine for finding out the mechanism of vision. Another important example of photochemical reaction is photosynthesis of plants. What is this photosynthesis? The capture, storage, and release of sun's energy or solar energy, where the water and carbon dioxide gets converted into carbohydrates and oxygen. This occurs in the presence of chlorophyll. The chlorophyll present in the leaves traps this solar energy. It takes the water through the roots and carbon dioxide through the stomata of the leaves, and they both react in the presence of this light energy and gives rise to oxygen, which is released into the atmosphere, and the sugar, which is converted into starch and stored in the plant. For knowing the mechanism of this photosynthesis, Dr. Calvin and Dr. Marcus have been awarded Nobel Prize in the field of chemistry. Sun is considered as the god because it is the source of energy. By utilizing this sunlight or light as the source of energy, you can do the chemical reactions too. And nature is doing that in the form of photosynthesis or in the form of vision and so on and so forth. Chlorophyll absorbs the light and it gets activated. The electrons in it gets the excited state. That is that the chlorophyll is electrically excited. This excited chlorophyll combines the carbon dioxide and water molecules and gives rise to glucose and oxygen, and chloroform gets reduced from the excited state to the ground state. The delta G here is negative, and the whole world is surviving because of the photosynthesis of plants. And we can utilize this in doing certain chemical reactions too. Chemical reactions accompanied or induced by light as photochemistry. In other words, it is the study of interaction of electromagnetic radiation, that is light, with matter that results into a physical or a chemical change. Action of light that induce chemical change is photochemical reaction, and the process as photochemistry. The chemical reactions that induces light is chemiluminescence. Light is an electromagnetic radiation which is made up of small particles called as photons. What is this photon? Photon is the smallest amount of light or the particle that carries energy with it. The light wave or the sound wave or the water wave, it is represented over here. This is characterized by the wavelength. The upper portion is wave crest and the lower bulge is wave trough. The distance between the two troughs or two crests is called as wavelength and is represented by lambda. And the number of waves that arises in a unit time is frequency, which is represented by V. Wavelength and frequency gives the speed of that wave. Speed is represented by c, wavelength is represented by lambda, v represents the frequency. And is electromagnetic radiation. Light wave is electromagnetic radiation. It has electrical waves and the magnetic waves, and these electrical waves and magnetic waves are perpendicular to each other, and it travels. The electromagnetic radiations, we know that it is in the visible region, ultraviolet, infrared, microwaves, radio waves, depending upon the wavelength and the wave number or the frequency. And this UV light and the sunlight or the visible light has been utilized for carrying out the chemical reaction, and that is nothing but photochemistry. What are all the difference between these photochemical reactions and thermal reactions? The photochemical reactions occurs because the matter absorbs the light. When it absorbs the light, it gets activated, and then these activated molecules undergo reaction, and that is photochemical reaction. Whereas in thermochemical reaction, it involves the absorption of evolution of heat for the chemical reaction to occur. Photochemical reactions requires light. In the absence of light, the reaction cannot occur, whereas the thermochemical reaction can also occur in the absence of light. Photochemical reactions are independent of temperature, whereas thermochemical reactions are independent of light. In turn, they are dependent on temperature. The rate of the reaction is dependent in photochemical reactions on the intensity of the light that the matter absorbs. Whereas the thermochemical reaction, the rate of reaction is dependent on the intensity of heat, not on the intensity of light. The free energy delta G, E may be either negative or positive in case of photochemical reaction, whereas it is always negative in thermochemical reactions. These are the key differences between the photochemical and thermal reaction. That's why what won't occur by thermal method can occur by photochemical method. That's why we, as the chemists, use this energy for carrying out certain types of reactions. Photochemical reactions are very unique. What is that uniqueness? Is the subject of discussion. The photochemistry is governed by two laws. These are called as laws of chemistry. The first law of photochemistry is given by Grothus and Draper. Here is the Grothus and here is the Draper, and these two members gave this law. This Grothus Draper law is also called as the principle of photochemical activation. What it says? It states that only the light absorbed in the molecule can produce a photochemical change in the molecule. If light do not get absorbed by the molecule, there is no photochemical change. The second law is Stark-Einstein's law. This is given by Stark and Einstein. It states that if a species absorbs the electromagnetic radiation, the one particle gets excited for each quantum of radiation absorbed. These are the two laws which governs the photochemistry. Energy of photons is given by Einstein, which is represented as E. E is equal to h into V. H is Planck's constant. V is equal to c by lambda. H is the Planck's constant. It is given as 6.6 into 10 power minus 34 joules per second. Speed of light is represented by c, which is 3 into 10 power 8 meters per second. Lambda and v represent the wavelength and frequency respectively. The intensity of light and the energy of light plays a very important role in photochemical reactions. The energy of these photons is governed in turn by the wavelength of light and the frequency of light. Einstein's equivalency principle states that one particle of a substance can absorb one photon of light beam. That is represented as delta E is equal to H into V. If I have 1 mole of delta E is equal to N into HV, that is given as 1 Einstein. N represents the Avogadro numbers, H is Planck's constant, V is the frequency. One molecule of the substance absorbs one photon means 1 mole of substance that contains 6.023 into 10 power 23 molecules absorbs 1 mole of quanta of light. That is 1 Einstein. That is 6.023 into 10 power 23 quanta of light. And one particle can absorb one photon of light. इससे ज्यादा ऑब्जॉर्प्शन नहीं हो सकता है, उससे कम हो सकता है. The form of photochemical reaction is like this. The molecule interacts or absorbs the light, and when it absorbs the light, the electrons in it gets activated, and this is a molecule in activated state, which is represented as A star. This in activated state, it has higher energy. At that higher energy level, their kinetic energy increases. And when the kinetic energy increases, movement increases and the collision takes place. And this collisions leads to intermediates, which gets converted into stable products B and C. The photochemical reaction process is classified into two steps. The first step represents the primary reaction, and the second step represents the secondary reaction. In the primary reaction, the molecule absorbs the quantum of light and it gets excited. It is represented as A star. In the secondary reaction, the excited molecule reacts further to give rise to the product in quantum yield. The quantum efficiency is defined as number of molecules reacting in a given time divided by number of quanta of light absorbed at the same time. That is represented as psi. Experimentally, psi is equal to rate of chemical reaction divided by quanta absorbed per second, or quanta of light absorbed by per second. This equation represents the number of molecules reacting in a given time by absorbing the number of quanta of light absorbed at that same time. Based on this quantum yield, the photochemical reactions are classified into three categories. The first one is that where the quantum efficiency is a small integer like 1 and 2. Dissociation of hydrogen iodide and hydrogen bromide, combination of sulfur dioxide and chlorine, and ozonization of oxygen comes under this category. These are the few examples which represent this type of chemical reaction. Another set of photochemical reaction is one where the quantum efficiency is less than 1. Dissociation of ammonia, acetone, and nitrogen dioxide, transformation of malic acid into fumaric acid comes to this category. The reaction in which psi is extremely high is another category. The combination of carbon dioxide and chlorine, combination of hydrogen and chlorine comes under this category. The discussion of these reactions will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.